Hi, Mr. Green here again. I'm going to be taking you through the next topic of the energy section of the AQA GCSE physics paper. This section is on conduction and convection, and our learning objective is to explain how heat transfers in solids and fluids. Please pause the video whilst you write that down. Okay, retrieval practice to start with. If you pause the video whilst you answer those 5 questions, restart it when you'd like the answers. Okay, question 1. What's the most dense state of matter? That would be a solid. Which is the least dense state of matter? That would be a gas. Again, remember, density is how closely packed together these particles are in the solid. And they're really close together in rows and columns. In a gas, lots of space between them. Question 3. When will a solid object float in a liquid? That will occur when the solid is less dense than the liquid. So if you've got a lower density and you place it in a high density object, it will float. What's meant by the melting point of a substance? That's the temperature at which the substance goes from a solid to a liquid. And what's the boiling point? The boiling point is the temperature at which the substance turns from a liquid to a gas. Okay, our learning outcomes today is to describe how thermal energy transfers in solids, to explain what makes materials good conductors, and describe how thermal energy transfers in liquids and gases. Quick starter activity here. From the particle diagrams below, name the states of matter each one represents. Please pause the video whilst you attempt that question. Okay, so the first diagram we see there, that represents a solid. The second one represents a liquid, and the third one represents a gas. Particle arrangement is going to be very important today into understanding how heat transfers through any of these substances. So if it's a solid or a liquid or a gas, the way that heat transfers through there will be different. Okay? So, quick question. Heating solid there, we've got a metal rod which is covered in Vaseline. On that Vaseline we've stuck 6 paper clips and we've heated one end of the rod. Which of the paper clips will fall off first? Which one will fall off last? And explain why that will happen. Pause the video whilst you attempt that question. Okay, so correct answer here would be for A, paperclip A will fall first and paperclip C will fall last. This is because thermal energy transfers from where it's hot to where it's cold. So it will always flow in that direction. If one area is hot and the other one's cold, the heat energy, the thermal energy will always flow in the direction from hot to cold. So let's have a look at a solid. Particles in a solid are tightly packed together in rows and columns. Now because they're tightly packed together and they're in a solid, they don't move around, they have a fixed position, but they do vibrate, and they vibrate around a fixed point. So there's a central point that they vibrate around, and they vibrate around there. If we were to give this solid more energy, what do we think would happen to the vibration of the particles? Pause the video whilst you answer that one. Okay. With more energy, the particles would vibrate a lot faster, and they'd move around that fixed position a lot more. So the vibrations would be bigger. They would take up more space with their vibration. So let's have a look at conduction. If these particles on the end were to vibrate more, what would happen to the particles next to them? So if the particles at the start, that column of 3, started to vibrate more and more, what would happen to the particles next to them? If you're stood in a row of 4 people and the person at the back starts to push into the person in front of them, what would then happen to the people in front of those? Pause the video whilst you write down what you think would happen. Okay, the answer for this one is the vibrating particles would hit their neighbouring particles, and because they're vibrating, they keep hitting them. As they keep hitting them, they make those particles vibrate more. Now, when particles have more energy, they vibrate more, so a vibrating particle that's vibrating more has more energy. So this vibration passes that thermal energy down the solid, and this is what's known as conduction. A vibrating particle hitting the particle next to it, making that vibrate more, passing that energy on. The energy would go in that direction as far as that's concerned. The vibrations would pass from the particles at the left hand side all the way through to the particles on the right hand side, passing the vibration between particle to particle. Okay, quick progress check. Pause your video and answer those 4 questions, and unpause when you would like the answer. Okay, question 1 then. How are the particles arranged in a solid? Particles are arranged in rows and columns, and they vibrate around a fixed point. Question 2. What direction does thermal energy transfer? It always travels from where it is hot to where it is cold, so where the object is hotter to where the object is colder, thermal energy will flow in that direction. What effect does heating have on solid particles? Heating a solid particle makes it vibrate faster and further around that fixed point. It takes up more space, it will vibrate much bigger. And what effect would that have on the neighbouring particles? The vibrating particle would hit and keep hitting its neighbour, causing it to vibrate more, transferring that thermal energy on. Okay, got a picture there of a saucepan with a wooden spoon in it. Which would feel hottest, and why do you think this is? Pause the video and answer that question. Okay, keep that question in mind and your answer while we go through the next section here. We're going to be asking, why is metal such a good conductor? I've got 2 diagrams at the top there, one of a metal and one of a non-metal. Now you can see in the metal we've got the atoms in rows and columns, and they're vibrating from side to side, passing that energy on to their neighbours. But in between those layers of atoms, there's something else. In the non-metal, they aren't there. So what's this? What's it causing? Why is the metal so much better at conducting? It's because the electrons in a metal can leave their atoms and move around in the metal as what we call free electrons. They are free to move anywhere within the structure of the metal. When the electrons gain energy, they move through the metal faster and they collide with the atoms as they're moving around. They smash into them. And that causes those atoms to vibrate even more. As it's vibrating even more, that's passing the energy on a lot quicker, so it speeds up the heat transfer in the metal. In non-metals, they don't have these free electrons. They only have the vibrations of the particles to pass that heat transfer on, or that heat energy on. So the electrons aren't there. There isn't this extra boost to get that heat energy through. So the rate of conduction in non-metals is much lower than in metals. Metals are much better conductors because of these free electrons that can move freely through the material. Okay, quick progress check. Explain why metals are better conductors of heat than non-metals. Okay, the answer for this one is the metals have free electrons, so the electrons are able to leave the atoms and move through the structure of the metal. These electrons can gain the energy from the heat that's being transferred to the metal, and they move through that metal, colliding with atoms, causing them to vibrate more, speeding up that heat transfer in the metal. Okay, we've looked at solids now, but let's look at fluids. Fluids can be defined as a state of matter where the particles can flow. So examples of fluids would be liquids and gases. Fluids don't conduct heat energy. Why do you think they don't conduct heat energy? Pause the video and answer that question. Okay, conduction happens when particles vibrate. And particles in a fluid can move. They don't vibrate. When they gain energy, they move around. So how does heat transfer through fluids? It can't be conduction, but we know when we put water in a saucepan and heat it, the water gets hot. Heat must transfer through it. How does it do that? Bit of revision before we go into the details of it. Our revision's on density. So, density is equal to mass divided by volume. So particles in a dense material are much closer together than particles in a lower density material. So if the particles are really close together, it's very dense. If the particles are really far apart, it's not very dense. If a low density material is placed in a more dense material, it flows. So wood is not very dense, water is a lot more dense than wood. If I was to place wood into water, the wood would float on top of the water. Particles in a fluid do not vibrate, so what happens when we give them energy? They move more, and they move further apart. Particles in a heated fluid are less dense than particles in a cooler fluid. You can see from the diagram there with the heated water, much more space between the particles. Room temperature water, there's still space but not as much, and water that's been chilled, the particles are very close together. So how would these particles move then if we heated the fluid from the bottom of the vessel? This is what we call convection. If I heat that from the bottom, the particles right at the bottom will gain energy. As they gain energy, we've just said when particles in a fluid gain energy, they move more and they move further apart. So at the bottom of that vessel, the particles will become less dense. Particles above are more dense. If we put a less dense object in a more dense object, it will float. So these particles float to the top of the fluid, they move up to the top of the fluid. What happens to the particles above them? Particles above are much more dense than the particles below, so they sink to the bottom. So the particles that have gained energy float to the top, particles that haven't gained the energy sink to the bottom. But as they sink to the bottom, they then gain energy from heat, and they eventually move up to the top, pushing those other particles down. It sets up what we call a convection current. If we continue to heat the fluid, the particles continue to rise and fall in what we refer to as a convection current. The more and more cycles the convection current goes through, the more the overall energy in the fluid increases. And if we continue applying heat, the more that occurs. So convection happens because wherever the fluid's being heated, those particles become less dense and rise to the top of the fluid. Remember, a fluid is a gas or a liquid, so this happens in air, this happens in helium, this happens in all states of matter where particles can move. When those particles are heated and they become less dense, they float to the top. The more dense particles above sink to the bottom, and then they gain the energy, rise, and we set up this current, this cycle. Okay, to finish off, quick progress check. 3 questions. Pause the video whilst you answer those. Okay, so question 1, what's a fluid? Fluid is a material where the particles can move, like a gas or a liquid. Why do hotter particles rise in a fluid? The hotter particles move apart and become less dense. When we give energy to particles that can move, they move more, so they move further apart. They become less dense than the particles above. And again, something that's less dense in something that's more dense, the less dense substance will rise up. Why are radiators always placed near the floor of a room? This allows hot air near the heater to rise up, and it creates that convection current. So the hot air the particles that have been heated will rise up, the colder particles will sink down and they'll get pushed towards that radiator. They'll then gain that energy and move up. The particles that had previously gained energy get pushed down. They move to that radiator, they gain more energy and rise up again, pushing the other particles down. Overall, the more and more convection current we get, the longer that goes on, the more energy is placed into the room, and eventually the whole room becomes warmer. Okay, I hope that lesson was useful for you all. Lots of videos available on our YouTube channel for you to revise or work on. Thanks very much for listening. Goodbye.